Yo, what's up? Welcome back. Today we're working on my stream intro screen. So the idea is we're getting kind of close here. This is like almost resembles what we want. We have like this like kind of like program-y, command line-y animation that's going on that we're rendering in OpenGL. It like updates, we say what we're going to work on and like when the stream's going to start. And this plays for a little bit before stream gets going so that people can like, when there's time to like catch the intro and stuff line so you don't miss anything, as well as like run some pre-roll ads or run some ads to disable pre-rolls on Twitch for the first like hour of stream, which is pretty useful. And what we want to do is we've got like this like CRT on a table in the scene, and the eventual idea is that we're gonna like put a camera in front of the screen and we're gonna render this on the CRT itself. But we want it to look like kind of okay, and like we're using this as an excuse to explore 3D rendering as a whole. And so we're kind of like, instead of doing this in like the logical thing, like a game engine or something, we're just implementing this in raw OpenGL. And so this is kind of approximately where we're at right now. We have like something rendered, and it looks kind of shitty, right? It looks kind of bad. And I would like to see some form of shadows, right? Like if I open up this like reference scene from Blender that we did to make like check if this was something that we wanted to try, it would be nice to be able to get like some of this like shadow stuff going on, because it just like looks weird without it. I think like the scene looks just strange, and I think shadows are like really the only piece that's missing to make it look okay. We'll find out after we implement them if there's more that makes it look like shit, but we'll see. And so we started on that last stream. We didn't get super far. But the overall idea is that if we have a light source over here, and there's like something here and something maybe like over here, right? The idea is the sun is really big and far away. So we kind of, instead of modeling this like something that shoots rays in multiple directions, since the sun's so far from Earth and so big, essentially all light coming in from the sun is coming in essentially like completely flat. So we kind of think we can like render a scene from the perspective of the sun, and basically check how deep each ray from the sun makes it into our scene, like say they have the ground. And the idea is we'll find out that like all of this stuff, hold on. Like all of this stuff is in shadow because none of the rays from our like light source are hitting it. And so if we render the scene from the perspective of the sun, we'll have that information of like the whole world and how it looks in terms of like depth. And then when we render the scene from the perspective of our camera, right, our camera's like over here. He looks like a box for some reason. He's like looking over here, and he can say, well, I'm looking at this point. And if I like look at this point from the point of view of like this depth that I just rendered, is it like deeper or farther than like the highest up surface? And that should tell us if we should be in shadow or not. And then if we're in shadow, we can just like reduce the brightness of that surface. And so last stream we were starting with that. There's a couple things to think about here. One is that if your light rays are coming in completely parallel, you want like no perspective on your camera. You kind of want everything to be like completely straight. Otherwise, if you had like perspective, it would seem like your rays are kind of like going in like different directions based off your angle of view. And the other thing is we need to like know if we have like a light source that says we're pointing light this way, we kind of need to figure out how to like position our camera in a way that it's pointing in the same direction. So last stream we were looking at this look at function that we stole from what is it? GLM look at implementation, I think is what we were looking at. Yeah, we stole this implementation of look at, which basically says like I am, and here is where my eyeball is, here is where I want to look, and this is the direction that I'm going to consider like up in my view. So the first thing we have to do is finish looking at that, because we got kind of stuck on some of the algebra there, and it wasn't working correctly, and I think I understand why now. So we're going to say fix look at function. Then we're going to render scene orthographically, pointing towards center of world, right? Because then we'll get our depth buffer to that. So we have to render that to a texture. Then we are going to when rendering real scene, use the texture and remap coordinates to texture frame. I don't know if that's like quite the right texture frame of reference, I guess. I'm not sure if those are like quite the exact right words, but that's approximately what we want to do today. So I think we're good to start going. So let's fix this look at function first. We'll say this is the first thing we're doing. Okay, so just let me check out the version. I was to actually show what we saw there. What am I saying? I was backed up a couple commits just because we were in like a bad state when we had to stream yesterday. Oops. Let's paste this. And let's go look at our look at function. So I think it was in matrix, our matrix stuff, and we probably said look at, here we go, yeah. And we copied this function that essentially it took, I didn't really understand what it was doing before, but they're basically coming up with three vectors, like 3D arrows, based off of the ones that we put in. So we kind of put in, I put in like, hey, my eyeball is here. I want to look at this thing. And I want to consider the sky up, right? If we have like, we have like the sky over here and the sun. We want to say like, up is this way. And I want to look this way. And so from those two things, you can calculate a third vector, which is like which way is sideways, essentially. So then you can say I have sideways, up, and forwards. And then they do this little trick where up and at this thing need to be like orthogonal to each other. So if I said I want like this to be up and my point is actually like kind of like further down, these might be at like, oh god, this angle keeps looking like it's 90 degrees. But basically like they do this trick where my up might be pointing in a way where like this angle is too small. And so then we just adjust, we kind of like move this arrow back a little bit to make it orthogonal so that we have like our three axes. Then all we have to do is say like my old x position, like my camera's x is going to turn to be this direction, up is going to be this direction, forward's going to be this direction. So they just like calculate forward, up, and sideways, and then do like the fix to make up orthogonal with like cross products, because cross products give you a vector that's like orthogonal to the two you look at. So this forward is doing center minus eyeball, up is just going up, and they're normalizing all of these so that when they put these into matrix, they don't end up like scaling the world incorrectly. So that all makes sense. And so they're just like applying these. Essentially, they're saying like they put these in a matrix so that when you multiply like x, y, z, 1 by this thing, you get like side, side, side. So this will turn like x into like the new sideways. You get like up, 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 because this will turn y into the new up. And this will say forward, forward, forward. That all makes sense because you just multiply x by these s's, you multiply y by these u's, you multiply z by these f's. Great. And we got kind of stuck here because they're doing this like dot product here to do like a translation, because you add this to like this 1 times this translation. So if you say like 1, 2, 3, you would think that the camera should end up at 1, 2, 3, but they're doing like these like projections of the eye of like where the position of the camera is onto the new sideways, up, and forward vectors. And I couldn't like understand why they were doing that. And we were just like, fuck it, I don't know. And then we tried like just flipping around some negatives because we were concerned about like order of operations or whatever. And I realized after doing some reading yesterday that the reason they're doing this is because normal OpenGL people, they to get things in the field of view of the camera. Hold on, let's make a new scene for this. Say I have this box, and the box is the only thing in my world. Right, we'll put the box over here somewhere. And let's put my camera at 0, 0, 0. Oops, that's the box. I want to move the camera, not the box. Put the camera at 0, 0, 0, and we'll point him towards the box here. Okay, so what I'm doing for my OpenGL world is like, or my OpenGL coordinates is I'm moving the camera around, right? Saying like, I want the camera to be here. And then finding the inverse of that matrix to say like, okay, if I'm rendering this cube, where do I put these cubes so that the camera is in the center of the world? And you can kind of like say, well, I'm going to like undo this whole movement and put everything right here. And you can do that by calculating like, an inverse matrix at the end. Most people skip that step. And if I wanted like this view, instead of doing what I did, is they actually convert they move the whole world to match the camera. So they do something like this. So if I wanted to look at like this corner close up, they would do like take the cube, rotate it, and move it back. And there's like an important difference between those two because order of operations basically flips for those guys. So you can imagine that like if I wanted to get, let's say this cube also starts at the center of the world. So I could say that I want to move the camera back a little bit and then rotate it around the center of the world to look at that corner. Great. That's what I was thinking of doing, right? I say move it back, then rotate. But if they wanted to do it the other way, if they moved the cube forward, then did the same rotation, all of a sudden that doesn't work because I'm rotating around like the center of the world all the time. So if you're moving the cube, you actually have to rotate first, then move, if that makes sense. Where if I wanted to move the camera, if I would want to move then rotate. Basically, like all order of operations are flipped. And so what they're doing here is they're projecting their movement onto the new coordinate system with these dot products because they needed to do the rotation first. But I'm saying like, fuck that, I want to do the movement first. And so in my world, we can just, instead of doing these dot products, since I'm doing it the other way, I can just use the eye position directly. And if you look up like, why don't you just use the eye position? Everyone's like, well, because like you're thinking about it wrong. But I'm not, because I'm doing something different in my shader. And I'm also looking forward, not backwards. So I think if I do this, I'm pretty sure that if we run our code that says like, hey, let's rotate the let's put the camera at position 0, 2, 0, 2. So like only move it in Z, look at the center of the world, and keep Y up. I think that this should look reasonable now. Let's see. We're also doing some toggling of orthographic view occasionally, so that's why we're seeing this movement. And that looks pretty good. And let's try doing something like if we rotate the camera around the center of the world. So we'll just say like, let's make its position, his X position will be related to the cosine of time. And the Z position will be related to the sine of time. And I think that this should basically put us like rotating around the camera, around the center, which it looks like it's doing pretty well. Where yesterday when we did the same thing with our old implementation, it didn't work. So I think that like that's looking pretty reasonable. And we can also do something like, well, what if we put like the camera like up 2 meters as well? We should be, it's kind of making me sick with the perspective stuff, but I'm not really sure. I'm not positive that's right, actually. Not positive that that's correct. Oh, we can't move it. Can we still have Y be up here? I think we can. I'm going to multiply these by 2 as well, just to get it looking a little good. And I'm going to disable the perspective bullshit because it's hurting my head. Oops, I want perspective on, actually, all the time. It does look like we are not always looking at the center of the world. So it looks like maybe we actually did make a mistake here. So let's double check this. How can we think about this? I thought I had it yesterday, but it looks like as soon as I start adding some Y in there, it looks kind of fucked up, right? Like if I put my Y back to like 1.0, maybe make it like a little lower. It's close. The center of the world should be the monitor. So it looks like in some cases it's not doing what we expect. We can actually kind of look at what's going on here. It looks like the positioning of the camera is correct and the rotation is not quite. So let's maybe look at this. It could be that are you rotating around camera up instead of world up? Is that what I'm doing? Could be. Let's think about this. So we have the center of the world and our eye position. We're taking the difference between those and setting that to be forward. So we could actually try doing something like not modifying our x and y vectors and only modifying our z vector. Does that make any sense at all? No, it doesn't. What's Lookout supposed to do? Rotation around some point in space? Lookout is supposed to take like a position for the camera and a position that you want to see as the center of your screen. And it's supposed to make it so that that's what you're looking, like take that to, no matter where the camera is, look at this specific point. And we're close, we're just a little bit off. So let's just double check this. So we're saying we want to look at the center relative to our eyeball. Let me double check if these negatives on Z were supposed to be there. Definitely not. Definitely not. Maybe this is doing the translation first, then the rotation. Let's just not include translation in here. And we will just manually... Sorry, let me think about this. Let me think. It could be that those dot products were important. But I thought that I understood this when I tried it yesterday. So yesterday, I only tested up until y set to 0. Which, oops, I left this commented out. And that is working correctly. And so let's think about this. When I put y up, what is happening? We'll put the... It looks like we're kind of rotating. Is there like a point in space that is staying in view here? It looks like not really. It looks like not really. If I put my cursor in the center of the screen, maybe we'll move y down to like 0.2, and maybe that'll give us like a little bit of a better idea of how it's warping. So it actually does look like as we rotate, our y is moving up and down, probably by about as much as we are adjusting it. And it's possible that our rotation is always correct, but it's just our translation along y is not correct. But that's not true because, well, let's think about this. Let's put this in Blender. And from the perspective of the camera, I put, like, say I put the camera here and I tell him to look down like this. So you could get everything should be translated up. Like all things should be translated up if I rotate this. If I rotate the camera or move it. But what we thought we were trying to... What we think that we're setting when we say set camera transform is we think we should be setting the position of the camera and the direction that the camera is looking. And so our matrix showing this, like showing a 0.2 on y unconditionally, does seem like it's putting the camera in the right position. So let's think about this another way. So can we break up this matrix into two things that happened back to back? That might be interesting, right? Because we're essentially saying that we want the camera to be in that position no matter what. So we could structure this as two transforms, one that is the rotation, and we're pretty sure that rotation is right. So we could say, first we do the rotation, don't do any translation at all. And then we'll do the translation after or before. Do we do the translation before? No, if we want to do it after, and we essentially just want to do it after and only move it along Z by the distance that is the difference between the center and the eyeball, right? If we know that we're looking in the right direction, we just have to move backwards until we're far enough away. So we could try that. We could say let movement or let translation is basically equal to a identity matrix, i.e. this would not change anything. And then we could move it backwards. So we can say transform on the Z position translation is basically equal to the length of center minus I. So we can, I think that I have like a length function here somewhere already. Length. Oh, here I calculated the length, but I didn't split it out. So we'll say pub function length of vector returns a scalar float, and we just move this stuff out. And we return this guy. And then we say here, let L is equal to length vec. Cool. Cool. So length here. And this might be backwards. We might have to make this negative. In fact, I think we do have to make it negative. And then we're going to say, we're going to do rotation times the translation. And see if that fixes our problems. It looks like no. Maybe we have to do the translation first. I didn't think so, though. I feel like I'm confused now. Yeah, neither of those are doing what I expect. So why is that? Why is that? I must be misunderstanding something. I must be. Let's just not invert this, just to double check. Yeah, here it looks like that makes me rotate around the camera, which is just not what I was expecting at all. And so why? Damn it, I hate it when I read and I think that I understand and then I find out on stream that I'm definitely wrong. Let's think about this. So maybe what we could do is we could keep the camera stationary and apply this transformation to an object in the scene and kind of see what that looks like. Is my view frustum inverting? So I think what's happening is stuff is ending up behind the camera, and the camera isn't culling the stuff behind it, so it gets like flipped and backwards and stuff. I'm pretty sure that's what's happening. But I could be wrong. So let's say that we are going to make the camera stationary. We're going to put the camera maybe like whatever we did here. So this guy, he's saying that like I am rotating around Y, so we're just not going to do that. So we're going to say that this is like maybe some amount in the air. And I just want to see what this is doing. Cargo run. Okay, let's move it back a little further. So here we want like maybe 2.0. Okay, and then maybe I can like instantiate an object in the scene and have it look at the center and rotate around, and we can kind of see if it's doing what we expect and kind of like maybe infer how our look at is broken. From there. So we can say let test object position is this. And we'll actually do this in our render loop. And let's just say that the monitor will just run relative to this test object position. And let's see what that does. Yeah, okay. So we can see here that it's rotating around its own center, not the center of the thing it's looking at. So if we go to our look at and we flip these guys, still? So that's really fucking weird. That's not what we expect. Not what we expect at all. Let's think about that. That's very surprising to me. I would think that rotating and then translating an object. Let's see. Like, I thought that these things stack together. So I do like a rotation, translation along Y, then rotation around Z. I would think that we should stay looking at, we should like rotate around the new center of the world. But that's clearly not what's happening. So it could be that I'm not understanding this, how do I say this guy? This like axis to rotation thing. So we can maybe try, instead of using this look at just temporarily, we can try combining the transforms manually and see. So we could say, hey, I want you to be a rotation around something. So we can say from axis angle, we want him to be rotating around the y-axis by self.time, and the axis is the axis mat axis y, and we want to do that after we do a translation in, what do we say this was before? This was in like Z. And these should be with .0 F32. Okay. See, this is more what I expected. Is I expected to see your translation is the identity matrix, isn't it? Is that true? Oh my god, damn it. Dude, you have saved me so many fucking times in my life. Holy shit. I thought that I was applying this to the translation array, this like backwards movement, but I was applying it to the the original one. So that explains that. So I think that like the concept probably was right, and I was just a fucking idiot again. Once again. Okay, so does this do what I want now? There we go. That's exactly what I expected, I think. It's hard to tell because he's so far away, and perspective is maybe tricking me. Let's bring him a little closer. So we'll put him like 1 meter away. And let's put him more in the air. So like 0. Or maybe 1.0 in the air. Just like put him up. So now what are we seeing? We are not seeing him move the way we expect. We see him circling the object. I see. We're seeing him circle the object because we've only moved him backwards after looking at the right spot. Does that mean that like one of our axes are inverted here? Hold on. Let's look at that again. So what I'm expecting to see is I'm expecting him to kind of move like always. His position should be constant around the top. Let me double check that I got the order of operation on those matrices right. I want him to do, I want him to do the rotation then the translation. That's why. still a surprise. So here his angle is not staying correct. I want kind of to see him. I want to see like one point on him always looking downwards, and that's not happening. Is that possibly, even without this translation? That's still not what I'm seeing, I think. I would expect to see one face of him kind of staring at, like, pointing in a direction. Like, how do I say this? I'm expecting to see, I'm rotating, like, around this way. I'm expecting to see, like, arrows always pointing inwards like this, right? And so if I attach that to, like, a monitor, I kind of expect him to be, like, angled down and then screen here, but angled down again. Wow, this is not visualizing well. Maybe I'll visualize in Blender. What I'm expecting to see is essentially this, where one face is always pointing that way. Even with, and like one face is always kind of like angled up. So let's look at this guy again. We're going to take this translation out completely, which we've already done. And let's think. So the Y position of the camera turns into the new up. Seems reasonable. Before they had these negatives on Z, I don't really understand why. Let's just see if... And yeah, that doesn't really change jack shit. That does not change jack shit. Okay, let's go back here and try a less aggressive Y movement on my look at. So if I set this back to 0, this behaves as we expect, right? We're rotating, we're moving our like X and Z, and we're rotating along that. So it's just like our off-axis rotation on Y is causing problems. Could you explain how Lookat integrates into things like the input and output? So yeah, the input is supposed to be, I give it X, Y, Z where I am. Then I have like X, Y, Z what I'm looking at. And it's just supposed to give me a like 4x4 matrix back that's supposed to be essentially like A, B, C, or how do I, maybe it's easier if I draw this as a, so matrix multiplication. If I have like a 4x4 matrix and I multiply a 1x4 vector, multiply it, what this ends up being is like this times this element, this times this element, this times this element, this times this element for each row. So I should get like, if this was like S1, S2, S3, I end up with like X S1 plus Y U1 plus F Z1 plus I don't know, whatever this, we'll call this like G for now. G. And then we do this for like each row. And that will become like our new number. And so what, like, theoretically, if I understood this correctly, which I clearly don't, what should happen is if I set like these 3 elements to like a new X position, this X, like the old X will turn into this new X essentially. Like if I draw like my axes like this, and then I like rotated my axes so that I had like a new coordinate system, but in the old one, I can like basically say like, oh, this was old X, this is new X, and so like this is where it should end up. This is old Y, this is new Y, that's where it should end up. That's what's supposed to be happening. But I'm clearly getting it wrong. And so we're seeing that the up axis is maybe not working the way we expect. Right, if we look at this guy again, let's see how he's moving. He's rotating around like his Y position, not like the world Y position. Is that right? Hmm. Hum. I think that's right. And so why would that be? It could be, so when up is 0, our forward is definitely looking correct. We could double check what our like forward, up, and side vectors are supposed to be. So we can just log here and we can say print line forward is forward. Up is up, and side is side. And we need to maybe debug log these. Okay. And let's run this and just kind of see what we get. And oh, sorry, we also have to log what our eye and center positions are. And these also have to be debug logged. Okay. So in the case where we have our eye at some some position, center here, we see forward is looking like let's try to draw this out maybe. Up is still up, which is interesting. Sideways is sideways. So here we have our X position is essentially 0. I guess what we should do is we should just not do any of this rotating shit. We shouldn't like draw anything. We can just try different values. So let's just say in main, let's just hard code some shit. So let's say that our position is 0 on X, 1 on Y, 1 on Z. And we're trying to look at the center of the world. Let's just run this and see what we get. We need to return okay. Okay, so here's our eye. He's here. We're looking this way. We are looking forward is nothing, no change on X, which makes sense because we're on the X-axis. We haven't moved on X at all. And he's looking negative Y, which makes sense, and negative Z in approximately the same direction. So all of that seems reasonable for like forward. That's towards the center. Up, he has as straight up, which I think is not true. And he has sideways as along the X-axis. Is that correct? So let's draw this out. We'll look at it in Blender, actually. So, can I, like, set my world up in Blender? I would like to have my coordinates matching. But I guess we can just do it with Z up and figure it out. Like, try to make sure we understand. So the thing I'm worried about is we'll take our camera. And we want him to be along X. And so in this, I think my sideways is actually wrong. I think. Because he's like kind of up. And we want to be looking at the center of the world. So we kind of want this guy to be kind of like pointing this way. And in this world, if I have like up this way, forward is pointing down and to the left like it should be. I would think that my up should look like this way, and my sideways should be along the y-axis, or the z-axis in this case. And it's not, so this looks suspect. This looks very suspect. Let's just double check this, because my cross product should give me a new orthogonal vector. And so if I have one thing that is basically down, like on the YZ plane, and up is on the Y plane, oh no, that makes sense. My sideways should be on the X plane. But that means... Oh, sorry, I've got this backwards. That's because I don't understand what I'm talking about. My mental model is wrong. I have no X movement, which means that he's actually looking this way. Yeah, that makes more sense. So sideways is still X, which is correct. Up is perfectly up. And so I think maybe the up vector is where I've gone wrong here. Oh, fuck. It's because I'm logging in the wrong spot. Trying that again. There we go. Okay, that makes more sense. So I think that my up, sideways, and forward vectors look reasonable in this case. They look reasonable. And so what happens if I draw... what happens if I draw the guy at that position? Let's see. So let's just hard code his position to this like I wanted it to. So if this is X, this is Y, this is Z. He is looking down into the... He has been rotated to look down into the left, which seems reasonable. Okay, and now let's do the same thing, but let's move him along Z instead of along Y. And we should see, this is where it starts to look fucked up. Is, here he should be angled down and he's not. So why is this broken? So his eyes at along X and along Z. Oh no, this is fucking right again. God damn it. God damn it. I swapped the wrong axes. I want him to be up in the world on Y along X. Okay. So here, I've moved him along X and along Y. So up. So now my sideways should be along Z, which it is. And my up still is like biased towards Y, but now along X as well, which also makes sense. Okay, so these rotations actually do seem reasonable. So let's add the translation back in and see if that makes sense now. Because we kind of took that part out, so. We just hard code this to never move. And I guess it would be nice to have, instead of rendering this monitor, let's render a set of arrows. Or maybe, yeah, a set of arrows, because then we'll have a better idea about which way he's supposed to be pointing, and that'll help us debug a little bit, probably. So we can just make a new mesh that's kind of like a set of axes. So we'll add a cylinder. We'll shrink him a lot because I don't think we need him to be this big. We'll scale him this way. Maybe we shrink him on this axis. How big is this guy right now? We want him to stay like relatively small. So he is 1.1 meters tall. So we'll just decrease him a little bit. Maybe we want him to be, select all, scale in all axes, I guess. 0.7 meters tall, we can go even smaller. 0.4, that seems reasonable. Okay, so this will be our Z. And we'll duplicate this guy and rotate him around X by 90 degrees. And this will be our Y. This is forward in Y, I guess. And we need a new one of these rotated around Z to point towards X. Okay, and so is this positive? That's negative X, positive Z, positive Y. So this guy actually has to be inverted. Inverted this way. What am I doing? I want to scale him in X by -1. There we go. And then I guess we just add some like cones so that we have like a direction so that we can tell which way is supposed to be forward. So we can say add in a cone, shrink him a fuck up. There we go. It looks kind of like an arrow, right? Okay, and we duplicate this guy. How do I like select linked? Control L. Duplicate, rotate along, rotate over X by -90, duplicate, rotate over Z by -90. Okay, so now we have some arrows, and the last thing that we just have to do to these guys is we have to color them according to their axis so that they are easy to look at. So we can just say, let's UV unwrap these guys. Cool. And let's take a blue and color the Z guy that way. So I guess we need a new image to color on, and we also need to hook up that image to the material, otherwise he will think he won't know what I'm trying to paint. There we go. So here we can just go like this, and I think there's a way to say, let's save this as arrows temporarily so we can look at it. And I think there's a way to say like, hey, could you like go through everything? Ah, fuck it. Fuck it. We'll just color it manually. I don't really care. This doesn't have to be perfect. It just has to be good enough that we can use it to get a feel for what we're looking at. Okay, blue. And we'll do a green one. And a red one. Why is this guy... Hello? Oh. What the fuck? Okay, so it looks like I should be able to go like this. Check your normals. Oh, because I inverted. I did that scale thing, and that probably flipped some. You're probably right. I bet you're right. If we where's the check normals button? Yeah, good call. Good call. So we can say recalculate outside. Perfect. And then here, when we UV unwrap, we probably have to fucking do our UV projection again, which is fucking annoying. And now we go back into whatever view lets us see the colors, and everything's fucked up, so we just have to recolor it. So texture paint, and we want red. Red, 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 red. Okay, and then we want to go back to blue, and we want to set blue everywhere here, so looks like we can probably guess that this whole section is supposed to be blue. Nice. And we're missing some green over here, so just kind of... Whoa, we're missing some blue here. There we go. Oh, that's kind of weird. The way this unwrapped is not the way I would expect. Is there some sort of like double... Are some of the texture coordinates overlapping each other if I color this in green? No? Alright. That looks about right. I think I see some green on here that I don't want to see. And some blue on here I don't want to see. But other than that... so the texture is probably not high resolution enough, but that's okay. I don't really care. This is just doesn't have to be perfect. It just has to be good enough that we can tell. So I'm okay with that. I'm okay with that. So we'll save this as the we'll save this as the color or the axes texture, right? Save this. And then we can export this guy as the axes object. We just have to be a little bit careful here because we need to make sure that the coordinates that these guys use, we need to make sure that their up axis is Z and the forward axis is, I think Y, I think. If we get this wrong, we're going to have some like absolute hell to pay. So we got to make sure we get that right. We have to say we need to triangulate it. And we won't export materials because we don't know how to deal with those. And I think that's probably fine. So here we will come over to the stream start screen and we'll call this arrows.obj, which seems reasonable. Or did we call it something else here? Axes.obj maybe? Seems reasonable. Okay, so what do we have here? We have axes and axes texture. And so here, when we are moving this fucking monitor around, we can just, instead of importing the monitor, we can pull in the axes, and the monitor texture, we can pull in the axes texture. And when we run this now, hey! Okay, so let's not apply any look at, just to see if our coordinate system matches what we expect. So here we go. We will just translate him and make sure that our translations match the arrows, right? So here we have X is Y up, which is good, Z sideways, X forward. And if we move him along X, okay, yeah, so, okay, cool. So we are seeing that our axes match. They match the expected thing. And so now we can go back to this look at, and we can say we have, let's put him at 1, 1, 0. Or maybe we'll just put it 1, 0, 0. We'll do a simple thing first, and we'll put this guy in that position. And we want to see Z pointing backwards, X pointing sideways. That's great. Wonderful. Let's go back to transform identity. And I just want to make sure that the way that the arrows are pointing still makes sense. So here we have a clockwise rotation from blue to red. And here we have a counterclockwise rotation from blue to red, which is bad. No, this is, yeah, counterclockwise blue to red. And when it was identity, we have, yeah, I swear that that's backwards. Right? Am I high? Let's photograph this so that we can save it for later. And we should also check, what is it supposed to look like here? So here, if we have Y up, if we're looking from the perspective of, oh, I guess it depends on which way Y is pointing. So if Y is up, we should be having counterclockwise rotation from Z to X. That seems reasonable. And so here, in our little picture that we just took, which I can find if I go into my screenshots, work, nope, not here, pictures. Here, Y is up, and we have clockwise rotation. Here, Y is up, and we have, this looks like different, this looks backwards to me, right? For the same arrows, we're seeing different colors. I rotated in the export. That's, so I guess maybe does that mean that, my forward axis has to be X, not Y? That seems possible. So we can say Kagero run now. No, that's definitely not right. What the fuck? Export obj. Dot. Goddamn, coordinates are really hard. Yeah, there's something about that doesn't feel right to me, but that's okay. Yeah, that's odd. That's odd. But we can say that in this world, we know that we know that after import, it has it this way. And so we can apply our transformation with a movement in Y. Oops. We forgot to apply, sorry, we were going to apply our test obj pause. And here with y up, we don't want to look at Blender here. We want to look at our reference image. With y up, we should see clockwise. So it could be that we've inverted x by mistake. And so we could go into our lookout function, and we could try inverting x here and seeing if that does something. Oh, which would make sense if our cross product is going in like some direction that we didn't really realize. Yeah. I'll bet you that's it. Is that our cross product like puts out a new vector pointing in some direction, and we got that direction wrong. Like our expected is different. So we can just say 0.0, 0.0, 0.0 minus this. And yeah, our cross product for up also has to be inverted. Yeah. And then we should get... And then our z has to go... Hold on. Where's our reference photo? This guy. So here we're back to clockwise z to x, right? But now our z's pointing backwards from the direction that we expect. So we guess have to invert. Why is that? Center minus I. Oh, because we want to look... Yeah, center minus I is forward. It's possible that our arrows are backwards. That seems possible. So I would like to go back to animating this and seeing if the arrow always points away. So if the arrow always points away... Oh, here the arrow is always pointing towards. All right. Oh, this is because... Fuck. This is because it's not the animation I wanted. So here I wanted to switch this to say that our position is going to be up a little bit. Let's just double check. And I wanted to rotate him around this guy. So we should say F32 sine self.time. F32 cos self.time. Ah, okay. So now we see something interesting here where our y is always pointing in the same direction, and our x and z are rotating around that same y position, which is just obviously not what we were trying to accomplish. And I bet that has nothing to do with our translation, right? Okay. Sick. So the question is, why the fuck? Why the fuck? So, can we do something like basically only look... How do I say this? So in the scenario where our y was not moving at all, this happens to be right because we're rotating around our y, which is aligned with the world y. Okay, we're getting somewhere. We are definitely getting somewhere. So this is x, y, forward. Each of these have x, y, z. Is it possible that I just fucked up the the order here of row column? That seems possible. Let's see what happens if I swap them. So that's... Now we need to put our y a little bit up in the air again. Ah, that looks a lot better. So I just fucked up row call. And then we can probably apply the translation again. Ah, that looks so much fucking better. We did it. We did it. Look at that. So, yeah, that's crazy. So I just fucked up row and column. So let's like reorganize this and try to figure out like how we misunderstood. So let's group the zeros, let's group the ones, and let's group the twos. And it looks like so row 0 has all X. So we actually drew out this matrix instead. We drew out X, 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 Y, 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 Z, Z, Z. And we multiply this by X, Y, Z. And so the new X is the X, Y, Z. Sorry, so this should be, how do we say this? This is sideways, up, forward. Oh, fuck me. Fuck me, of course. Okay, so let's group this by, here, we'll group this like this again. Ah, fuck me. Okay, that makes sense. So originally when we were saying that we initially said that we should be making the new X vector, we should be taking like the old X and putting it into new X, right? By saying like sideways, sideways, sideways. And we just weren't fucking doing that. And so like when I group them like this, now it's like pretty clear to me that that is happening, right? Because if we group by column and by, we can, yeah, we group by column. So we're like moving by rows, and we can see like the first column we're setting sideways, second column we're setting up, third column we're setting forward, fourth column we're setting position. Fuck yeah, baby. We did it. We finally got there. It took us an hour, but we got there, which is pretty fucking sick. Pretty sick. Let's go, baby. And so now, probably if we go back to setting the camera position that way, instead of this like object position, we can probably start seeing the camera doing what we expect as well. Probably. So let's try that. Camera position. And we can run this. Oh, we're inside the axes, so we're going to stop rendering the axes at that same position. We're going to put the axes at identity. Which was in main somewhere. Here. Transform identity. Let's go, baby. Fuck yeah. God, all of that for something so simple. That's sick, though. I'm happy. Okay. That is sick. Okay, so now, we need to set up a render that basically takes the direction of light that we're setting and renders the scene from that perspective. So somewhere we would basically say, we'll comment out the existing thing. And I guess we still, well, shadow mapping now? Yeah, exactly. So I guess we'll copy paste it. And we still are going to render everything in their like specific positions. They all haven't moved. We're still going to set the aspect ratio of the window. All of this is true still. It's just before we do any of this, we're going to say self mesh renderer set perspective enable false, because we're going to do an orthographic render from the perspective of the light. And we're going to say self mesh renderer set camera transform. And we're going to set the camera transform to match the light direction. So probably Is it possible to like pull that out of the shader? Sun lamp? Yeah, exactly. Well, kind of. We called it directional light source, but it's effectively a sun, yeah. So here we set the light direction, and maybe instead of setting it directly, we will save it in our update section. Like we've kind of broken up our app into multiple sections. One is like, hey, I'm going to update my like state, and then two is like, I'm going to render that state. So previously we were in our update loop telling the mesh renderer that we want our camera here and our light here. And I think maybe what we'll do instead is we'll save those things and we'll apply them in the render section. So we'll say light direction is a vec3. Which means here our light direction will initially be just default. It's going to be like 0, 0, f32 into. Cool. And then in our update section, instead of saying set light dir, we'll say self light dir is equal to this. This into like this, nice. And then in our renderer, we can say self dot mesh renderer set camera transform to be transform look at. Our eyeball is going to be I guess our eyeball is going to be at 0. We don't really know where we want it to be at. If you want it to be like a desk lamp sort of style, it might be useful to check out light attenuation. I guess that just means that you have like fall off with distance. Yeah, I see. So like your strength relative to the distance gets like exponentially lower. Is this exponential? Probably not. But yeah, I see what you're saying. I think probably, yeah, we'll see. We probably will want to get there eventually. But that just means that our one sunlight will probably no longer be sufficient. Fuck. I was initially thinking when I set up the sunlight, I was like, oh yeah, that's good enough that we probably don't need point lights. But you're right that if we want it to look like a depressing office, having like multiple lights with attenuation might look better. Might. But let's start with the sunlight. We're getting ahead of ourselves. We'll start with the sun and see how it gets. Okay, so our camera transform, we're actually gonna have to do like several things here, right? One is we're gonna have to like point in the direction of our vector. So we can start with the world at like 0. We can put ourselves at center, right? Into, and we'll look at basically the light direction. And we'll put our up. I think that it's kind of odd here. We have to set our up vector, but where our up vector is kind of depends on like if our light was directly above us, we actually couldn't have our light direction be up. So there's something to think about there, but for now we'll just set it to 0.0, 1.0, 0.0. And if that's problematic, we will fix it later. So this is set camera transform to a transform, so we throw a little ampersand on here. And this will put us in the center of the world, orthographic. Why use look at here? Yeah, good question. Because when I started writing this yesterday, I didn't have any idea what to do here. But I think it makes sense because we have a direction for the light and we want to set a rotation matrix for that direction. And so we still, like, look at has all of the same properties of what we want, right? If we have a vector that's pointing like this for light, we still need to pick an up direction, like, you know, either like this way or this way, and we then pick a sideways direction relative to that. So if we say like this is up, we need to make this sideways, and then we need to make a rotation matrix out of that. And so like all of that is like very similar. We're still doing all the same shit. Yeah, there is something to think about there though, where maybe you don't have to do that, but that's what we're doing. And then, so this will put us like in the center of the world, right? And maybe that's okay because we'll still render stuff behind us. And so maybe all we have to do is like scale the world to fit in so that like everything in the world fits. Because without perspective, I think that like we won't get any of those like artifacts from being inside stuff. I think. We'll see. Yeah, wait, hold on. Did I do the right thing? We're setting the camera transform to be looked at with the light direction. That does seem like it's working, except for some reason the light... I would think that if our camera position is in the light, we would always see the brightest side of things. And we just aren't setting light position, so... Mesh renderer, set light dir is just going to be self.light dir. Which I fucked up. It's a private field. Light dir takes... I guess we'll just make set light dir take a vec3. That seems reasonable to me. Which means that we need to use create mat vec3. And then this guy needs to go like this, and our function here needs to, instead of using x, these guys' values directly, he'll say x, y, and z. And then I guess he wants the length of this guy, so I guess we have this like pub function length. And I guess maybe it makes more sense for this to be like a member function on the vector. That seems reasonable to me. So this is going to take in a reference to self. And this is going to take self.0 iter. And then on this guy, we need vec length this. And everyone else is fine. So we can go back into our mesh renderer, and here instead of doing all this, we can just say length is equal to dir length. Nice. And I guess like what we're actually doing is we're trying to get a normalized vector here, so we could actually just also take out this like function normalize that we have a free function. We can also make this a member, because I think that makes sense. And instead of calling him normalize, we'll call him normalized because he's copying himself. And, yeah. That seems reasonable. This is self.y. This is self.z. And I guess, theoretically, we could implement a divide, but I'm not going to. And there we go. So now our normalize here should be taking center minus I dot normalized. This guy should be taking up dot normalized, and this should be minus cross normalized. Nice. I think that kind of like reads a little nicer too, maybe. Cargo check. Does everything build other than our unit tests, which are going to be fucking broken now? Looks like it. Main 312. We need to put an ampersand on this guy. And here, we want let... what are we going to call this? Normalized is equal to dir normalized. And then we just say normalized x, y, z. There we go. And we don't use length here anymore. Okay. So let's run all that now. And there, so now we're seeing that like no matter where the camera are, we're getting an orthographic view where everything is like as bright as it should be, because we're seeing that we are always the perspective of light. So that's pretty fucking sick. Pretty fucking sick. It looks like we might want to zoom out, maybe just a little bit. And so we can actually do this by, let's see. We can just scale in X, Y, and Z, probably. So I don't think I think I implemented a scale function at some point, but then didn't end up using it, so deleted it. So we can say function scale. Returns a transform. And his scale is like a scale in X, Y, and Z. And then we can just say let transform is equal to the identity transform. We return that transform. You mutate him, and we basically just set transform 0, 0 is equal to x, and 1, 1 is equal to y, and z 2, 2 is equal to z. We just set these on the diagonal, and that should scale everything down. Kind of interesting here. We probably don't need this identity. We should probably just make a new one because we're overwriting everything, and we'll just say 3, 3 is 1. Like this. And so I think that now if we want to scale everything from our perspective, we just apply that afterwards. Right? So we can say transform scale 0.5, 0.5, 0.5 times after they do a look at. And we throw another bracket on here. Bing, bang, boom. Wow, okay. Interesting. The scale is opposite from the direction I would have thought. Which makes sense, does it? No, that's backwards from what I would have thought. Oh, it's because we invert the matrix. Okay, sure. That's weird, but we'll live with it for now. Okay, there. So now we should be able to just take this, render it to a texture, and look up vertices in there. So let's start by figuring out how to render to a texture, because we haven't done that before. And I think it's as simple as just creating a texture. So we'll say let text is equal gl util create texture with default params, and we pass in our gl context. Which actually, do we not keep a reference to OpenGL in here? That's crazy. So we'll just glow context. We'll keep that guy around so that we can use him. And we'll pass him in here. We'll unwrap him because I don't ever see that failing. And then after the frame, we'll also probably want to free the texture. So we'll say self.gl delete texture text. We have to be careful here. This isn't like a scoped thing. So we may get a memory leak here if we returned early. What we should do is we should wrap this texture with something that will automatically free himself on drop. But we'll do that in the future. We have a texture, and then we have to bind him and basically say, hey, render to this texture, not to the screen. And so somewhere there's like OpenGL render to texture. So we bind the texture. Oh, we have to initialize him with data. That makes sense. Then they bind. Oh, they just bind the texture to a frame buffer. But is the frame buffer the same as the texture? Frame buffer, render buffer. Ah, okay. So you first make a texture that you're going to render to. And you make a texture for both color and depth. We don't care about color, so we might be able to get away with just making one for depth. Then we create a render buffer. If I remember correctly, there's render buffers and frame buffers, and those behave slightly different. One of them is like optimized for non-GPU access, and I think we don't need that. Frame buffer texture. Yeah, this is ringing a bell. OpenGL frame buffers. This is ringing a bell. So we generate a frame buffer, we bind it. Then we attach a texture to it. Okay. And they set, this is more what I'm looking for. GL frame buffer texture 2D. Yeah. And then they need to generate a second texture It's also possible to attach. Oh, you can attach a depth buffer and stencil buffer as an attachment to the single texture. So that's kind of cool. That's kind of cool. Okay, so I was wrong. I could have sworn that I was remembering that there was like a special type of buffer called a render buffer that you could render to. But okay. Yeah. Is the frame buffer how you get access to the second buffer and double buffer rendering? Probably. Yeah, that would be my guess. Maybe not. Double buffering could be handled by the GPU driver as well. Not sure. Because I would guess that if your frame buffer render, like even if you pre-render to a frame buffer, then render that to the screen in OpenGL, I would guess that you could still tear by doing that. But I could be wrong. But that would be my guess. So my guess would be that double buffer rendering is handled in the GPU, but what the fuck do I know, right? I'm reading learnopengl.com right now, so I wouldn't really trust anything that I'm saying is the truth. But my guess would be no. Okay. What am I remembering? I'm remembering like optimized texture for render buffer only. Render buffer storage. Use the target parameter of this GL render buffer. GL gen render buffers and GL delete render buffers. Is that what these guys are doing? Yeah, so why? I thought that you could render directly to a texture without this guy. But they are binding the frame buffer. All right. Oh, maybe it's that like they're not you can't sample the render buffer from a shader, but that's okay because we're attaching a texture to it and then binding the texture back to the shader later. All right. Fuck it. That makes sense. Okay, so once we've like let's see. So if I understand correctly, we have texture, which may actually have multiple buffers in it, like depth, stencil, color. We then have a frame buffer, which we bind the texture to. And then we have a render buffer that attaches to the frame buffer. Create the render target. So we generate a frame buffer, attach textures to it. What the fuck? Oh, I just held tab or something and just jumped around. They bind the render buffer. Gen render buffers. Bind render buffer. Set the storage. Depth render buffer. So none of this is related to a texture. Oh. I see what they're doing. So what they're doing is something different than what I thought. Let me just double check this again. Yeah. Okay. What they're doing, they have texture, that they have color. Then they have render buffer, which is depth. They have frame buffer that is mapping color to this and depth to this. I think. Frame buffer, render buffer, the depth attachment to this depth render buffer. Because then where do they bind the texture to rendering here? Somewhere they have to attach these things together. So they have depth component, and then where do they have like color component? Am I high? So they generate the texture. Somewhere, then they generate a render buffer for depth specifically. Here. Then they set the frame buffer texture to the render texture. But who Who is... Oh, so this attaches the frame buffer. Yeah. And then all they do is they bind the frame buffer to render. Yeah. Okay. So this goes back to my previous understanding of this. So if I remember correctly, render buffers are essentially specialized textures that you can't sample in the GPU. And the idea there, if I remember correctly, this is all like going off like shady memory, right? My recollection is that you would do this because the GPU can like optimize this buffer for specifically for CPU GPU transfer. And so in this example, they're doing it this way essentially because they only want to use color in their future thing. But we're actually in the opposite scenario where we want to use the depth output as our texture, maybe. Or maybe not. Maybe we'll use color and we could just make the color our Z position. I'll think about it. And then when they bind this frame buffer, they have like essentially like another thing that's like viewport. And when you render, it's either going to end, if you unbind all frame buffers, it'll render to the viewport. Otherwise, it'll render to the frame buffer. Pretty fucking sure. And so what we should be able to do is we should be able to create a texture. I'm also just noticing, I looked around and all of my lights are off and it's really dark in here, which doesn't seem to be making like too much weird artifacts on the screen, but it's bothering me that I'm so dark. So I'm just going to go turn on the lights. Just give me one sec. Much better. Now I'm bright and cool looking. Okay. Okay, so we create a texture, and then we just need to make a frame buffer. So we'll say self GL create frame buffer. Nice. Unwrap. Then we probably have to delete this guy as well. So we'll say self GL delete frame buffer FB. Okay. And then we attach the texture to the frame buffer. So we can attach him as so this guy's saying that we have to give him an empty image. And I guess that makes sense because we have to set the width and height of this guy. So that makes sense. So we'll bind the texture. Self GL bind texture. Text. The target is a 2D glow texture 2D. And the thing we're binding is our texture. We essentially upload an image to him, gl.text self gl text image 2D, which is a glow texture 2D. We're saying that he's RGB and he's 1024 by 768. That seems fine. Whatever. We can adjust these later if we want. But for now, those are fine default parameters. Like this. And he's saying, did I mean something? Cargo check. What is he bitching about? Because I need this to be as I32. Was it this one? And he doesn't like that this is 0, so can I like just write none here? Nice. So that should give me a texture that's 1024 by 768. I already have these guys set in my automatic, in my like little helper function to create texture params. Nice. We don't care about the depth buffer. And here is what we want. We want to set the texture for the frame buffer. Texture 2D. Why is this different? GL frame buffer texture 2D. What's the difference? What is the difference? Oh, they're both in here. Attach a level of texture object as a logical buffer of a frame buffer object. Shouldn't it only be depth though? For now, I just want to get color working just so that I can, and then I'll build up to depth in a sec. Because I don't really know. I'm worried about the depth transform. So when later I have to take a vertex and world position and match it onto the depth buffer. And if my depth buffer, I don't know if like the depth attachment on this guy is going to be in like a different coordinate space. So I want to get color working first because I understand that better, and then we can move on to depth after if we need to. You could also just like make a fragment shader that takes the depth and puts it in there, right? Like whatever. I'm not really too worried about it. Might be a little slower. So I would think that my texture is 2-dimensional. So I don't really understand. So I guess it depends. Level, target, attachment. So what is text target? These guys have a text target. Specifies what type of texture is expected in the texture parameter, or for cube matte textures, which face to be attached to. Sounds more complicated. And according to this, we don't need it. Which is interesting to me. Interesting. I guess we'll just do the stupid one and come back later if we need to. So we are frame buffer texture. The target is frame buffer? What the fuck does that mean? Like, specifies to which the frame buffer is bound for all commands. What the fuck? What does that mean? Oh, this is... like, I guess it could be render buffer or something as well, maybe. Which seems reasonable. Okay, we'll copy him and say frame buffer for now. Color attachment 0 seems reasonable. This is taking the color, and the texture is just going to be text, which we're going to say you have a texture to render. And the level is like level 0 because we don't do any mip mapping. Sure. Fuck it. Blaze it. And then I think if I just bind frame buffer. Fuck. We need to y. So somewhere he binds him, and we say that we're binding frame buffer. So I guess again that there's like, probably if I look here, they're sorted by name. I bet that there's like, I bet you could bind render buffer as well. That's my guess. GL bind frame buffer. Let's see. Target. Does he say somewhere what his valid targets are? Binds the frame buffer to the frame buffer specified. It must be either draw frame buffer, read frame buffer, or frame buffer. Yeah, okay. Okay, sure. We'll use frame buffer because we're going to read it back. Are we going to read it back? Maybe we're not. Maybe draw frame buffer is like faster and fine, but we'll start with this. Set the list of draw buffers. Whoa. What the fuck is that? I've never seen this before. That's new to me. GL draw buffers. What does this guy do? Specifies a list of color buffers to draw to. If a fragment shader writes value to one or more of the user-defined output variables, blah, blah, blah. For GL draw buffers, the frame buffer object is said, blah, blah, blah. Interesting. I wonder, but like if I don't set this, I would think that it would work the same way as when I render to the viewport. Because the viewport, I've never set this to render color to the viewport, and that's still working. So I'm going to try skipping this and just see what fucking happens. Okay, so we bind the frame buffer to FB. And we have to probably write the word sum in here. And then he's saying we have to set the viewport size. Because our viewport is probably... how do we say this? So we have like our OpenGL coordinate system that has like -1 to 1 here. But this eventually has to turn into pixels, right? And so they have to map this to something. So we just basically specify the left and right and top and bottom. So here we have 0, 0, 1024, 768. And that should fill the texture that we just put in there. And eventually, we'll probably have to, I don't know if we have to reset this or if the viewport is tied to the frame buffer. So maybe if we unbind the frame buffer, it'll go back. We'll see. No, we just fucking send it, I guess. So down here, so if we did everything right, oops, missing a little GL in here, so we'll just kind of throw up, whoop, womp womp. There we go. So what we should see is nothing nice. So this is kind of interesting. The cursor is still rendering not to the frame buffer, and why is that? Oh, probably because it automatically unbinds when I delete it or something. And so then what we should do is if I unbind the frame buffer here, frame buffer, bind frame buffer, none, and then I re-render the scene here, I think we should see the same thing. So here I think it was glow frame buffer is what I'm unbinding. Okay. And so now we should start seeing ourselves drawn to the screen again. But we can see that like the viewport size is fucked up. So we need to reset that probably. So we'll just say self geo set or viewport is going to be window width, window height with zeros. Like this, probably. I don't know. As I32, I guess. I don't know. Fuck it. We'll see. That looks reasonable again. And what would maybe be interesting is if we render, we could render the texture to something in the scene and see if we see anything that like matches up with what we expect to see. So we could like maybe put the camera, we could like enable perspective again and then put the camera somewhere like looking at the desk and put the texture of the scene onto the desk. That'd be kind of interesting maybe. That would be interesting. So here we're going to set the camera transform to like enable perspective. Set the camera transform to like, I don't know, transform. We have something that we can copy here. We'll just do this. Whatever this is. So here we move back and then up over Y. Sure, fuck it. Camera pause. Then we render. That's a bad camera transform, I guess. Why? Oh, because this is a really small angle. We want something like some small increase in Y, probably. What the fuck? What am I doing here? I move back in Z and then move up over Y. Why does this look like shit? What the fuck? I swear this never looked this way before. Am I high? Am I high? I might be. I might be doing something fucking stupid. No, okay. So that one looks fine. Okay, okay. Sure. So now what we should be able to do is put that texture on the desk. So we can say self.table. Right now we have like the texture just attached to this guy, if I remember correctly. Which isn't what we should be doing, but we will just, for now, is equal to texture. And when we render this now, instead of it being brown, we should see like the scene, which is mostly black, which isn't good. Not good. So what we could maybe do, we could double check our UV map for the table, or maybe instead we'll just shove a plane on there. Yeah, let's do that. So here we'll say plane texture. Fuck it. We'll just replace the table with the plane. because then we will have a nice clean UV unwrapping. That seems reasonable. Seems reasonable. Way to test for now. We're taking shortcuts. We are taking shortcuts. So we say, here is a plane. And we'll maybe scale it down a little bit, and we'll just say export OBJ. And we can put this in our stream start screen, and we'll just call this plane object, who is going to be triangulated. Forward axis Z, up axis Y, sure, fuck it, I don't care. Export. And our table will just replace with the plane. And there we go. Now we see this plane, and if we were to go back, not reassign the texture. Cool. We're seeing it brown again. And so now the question is there something we need to do to use the texture? Like, do we have to like make sure that it's finished or something? We're going to draw a simple quad that fills the screen, blah, blah, blah. So here they use the gen buffers, bind buffer, buffer data, yeah, whatever. Bind frame buffer. So they unbind the frame buffer, they render, they reset the screen, and they bind the texture. So it's like, where did we miss a step where we can maybe check this. We didn't actually check if the frame buffer went wrong. Well, so let's do that. Right, it could just be that what we're rendering is just not working correctly. So we'll say if self.gl.check frame buffer status glow frame buffer is not equal to glow frame buffer complete. We will assert false for now, or maybe panic with a incomplete frame buffer, right? And just kind of see, maybe we're not binding it correctly. And we are, in fact, saying that it's incomplete. So it could be that this step that we skipped, where we set the draw buffers, that just might be actually important. Could be, could be. So we'll say this is glow color test 0. We say that this is some buffer of GL enum, which is probably U32. So we'll say this is a let buffers equal to this array. All right, which is going to be like a U32.1. We've set the types here because we want to be very careful. We say glow GL self GL draw buffers, and we pass in buffers. Okay. And now is the frame buffer complete? Still no. Still no. So maybe they attach depth to the render buffer. Maybe we can disable depth rendering. So maybe we can say like GL self GL draw depth disable maybe glow depth, if I remember correctly. I think this is what we did. Glow depth. To enable depth rendering, we did have to enable this. So if I disable it, he's still an incomplete frame buffer. So can I see like why he's an incomplete frame buffer? GL check frame buffer status. I want to know why, you know? So we can check. Oh, I see. So he's going to give me an answer here. And so I can just print what he says. So we can say the frame buffer status is this shit. Right? Paste this bad boy. And then we say if the frame buffer status is not equal to this, we can say what is the frame buffer status? And he's going to print some fucking number. He's probably going to be in hex. Right? Just out of like, last time I looked this up as in hex, so we'll print it in hex. And so he's going to say that he got this guy. And we can just look for that number. but he's gonna have like uppercase numbers, I guess. Incomplete missing attachment. Which can happen if it does not have at least one image attached to it. So what the fuck were we doing here when we set the frame buffer texture? If not, fucking fuck shit. I was setting the texture before I bound it, so. Hey, that's kind of sick. And so you can see here on the plane, we are in fact seeing something that represents our scene inside the plane there, being drawn on top. Which is pretty sick. Pretty fucking sick. I guess maybe we can check if we set our camera position. We just don't reset our camera position here. We should see basically the same thing inside the table and outside the table. Approximately. Which is hard to see because it's inside. But yeah, I think that's right. Let's not rotate the camera, actually. We're just going to set our camera to, like, 0, 1, 0. And set our X as up, maybe. And then we should just be looking straight down at the table, I think. And let's not render anything but the table in our second scene. Yeah, that's pretty sick. That's pretty sick. So it looks like we are seeing this guy like get rendered on there. Oh, and probably before we need to reset his texture here. So we're going to say let table text is equal to self.table.text. And then after we render, we reset it. Because then we should see brown inside the table when on the second render. Yeah, I think that's right. So now we see like a little window into our render. That's so sick. And that's from the light position, light's perspective. And so now the only thing that we have to do is basically look up in this buffer. Well, first we need to convert this from color to depth, right? We're doing a color render here. So we need to switch that to a depth render. So we should, instead of this being color attachment 0, we should be able to say depth attachment. And here we should be able to say that I want to set this as the depth attachment. And that clearly does not work. Incomplete frame buffer. Let's think. We saw 8CD6. Incomplete attachment makes sense because we probably don't have our, if any of the frame buffer attachment points are frame buffer incomplete. Okay. So it's possible that we can't render depth to like an RGB texture. So we can go, I think I saw this concept somewhere in Shadows here, and they bound the texture as GL depth component instead of RGB. Okay. Which could make sense. Maybe that's required. Okay, let's try again. I disabled depth, by the way, which explains why it looks like absolute fucking dog shit. So we will just re-enable depth. And probably just rendering depth as color is invalid, maybe. Do we even see anything that looks sane in there? Maybe not. So here, we can attach it as this guy's. Oh, so interesting. These guys, they didn't do the same draw buffers call. They set the draw buffer and read buffer directly. And then later when they bound him back, oh, we do have to clear in between, which is a pretty good point. We didn't do that. And they just bound the texture as a regular 2D texture. So where are we doing like a clear? Are we clearing anywhere? Where do we like reset? Here we go. On each frame we clear, but we just should clear in between these two renders probably. And Jesus Christ, it's impossible to read any of this. I think it's here. We'll just put a big block in there for now. In the real world, or in the future, we will split these into functions, etc. But for now, we can clear in between, which may or may not be important. So now it's rendering. Oh, we have to clear after we unbind the frame buffer, of course. And it's weird that like our frame, oh fuck, of course. We also have to clear before we render the frame buffer. Right? Every time we bind the texture, we have to reset it. But I don't understand why it seems like we're having like continuation over time, which is kind of odd. Right? I would think that that's not reasonable. Oh, so I probably have to do it after we bind the frame buffer, not after we bind the texture. That's my bad. Yeah, there's something wrong there. Definitely something wrong. Maybe I'll do it right before we render. Ah, there we go. Okay, so that's pretty reasonable. That's probably a sane depth buffer. Almost certainly. But it's just hard to tell because the arrows are probably so close to the table's depth that it's hard to see. What's my Windows Plus? Right, you can like, if you ever so faintly, I don't know if this comes up on screen, but I can definitely see arrows in here and like the screen. It's just very, very subtle, which makes sense. Pretty sick. All right, so we have now rendered a scene orthographically pointing towards the center of the world to a texture. And we're, oh, do I want to keep going? It's probably worth continuing. Fuck. Okay, so I'm so short on time today, though. It would be really nice to finish this, but I'm just like, after stream, I have like some shit I have to get done. Okay, we'll go for like a little bit longer and see if we can like finish this off, and just hope for the best. Okay, so here, instead of rendering the texture as the table, well, what do we have to do? The like next steps would be binding this like depth texture to the shader, as well as telling our renderer that we need, excuse me, please don't move my chair. After we render, sorry, so we need to bind the texture. We have to set the transform and use that in the fragment shader to look up in there. Fuck it. I think I'm going to call it there. There's enough backup work to do next stream, so that if the shadow situation is like very quick, we can just move on to finishing up the scene on the next stream. Otherwise, I'm concerned that I wouldn't finish it in time today, unfortunately. So, okay. Thanks for watching. That's pretty sick. I'm pretty happy with that. We actually did make like a lot of progress today. Cargo run. Right? Like, that's pretty good. That's pretty good progress. So we went from having like a completely broken like look at function that we need to point the camera in the direction of the light. We fixed that, so some linear algebra shit in there. We learned how to like render the scene to a texture, and then we have like done a second render of the scene looking at the texture that we rendered, both color and depth. Pretty happy with that. So the only thing that we have left to do in order to like actually apply shadows is take this texture and do some lookups in it, which I think we'll do tomorrow. So thanks for watching. If you liked what you saw, I stream most days at like somewhere between 1 or 2 o'clock Pacific time. I don't want to say PST because I can never remember if Pacific Standard Time and Pacific Daylight Time, they switch sometimes. And in reality, when I switch daylight savings, we're going to be 1 to 2 daylight savings time. So Pacific time. And I stream for like 1 or 2 hours, longer than 2 hours. I think like if I was making content for myself, I wouldn't watch a YouTube video longer than 2 hours, but 2 hours I would watch. So try to keep it in that range. And we're trying to like start doing like a variety of things. So we've done some like operating system stuff. We've done some like OpenGL stuff. I have like a neural network that I want to train in the near future. So we'll try to vary it up. There's a YouTube channel. If you miss a Twitch stream, there's a YouTube channel linked in the Twitch description, and all the VODs will go up there. And if you're watching on YouTube and you want to come say hi, help me figure out my stupid bugs, there's a Twitch link in the YouTube description. Other than that, there's a Discord for people if they want to join and chat about whatever, shoot the shit, where I post like announcements and stuff. And there's a GitHub linked in the Twitch description as well, where projects that are in like a semi-reasonable state will eventually end up. So yeah, thanks for watching. What's my education? Education is just, I did computer engineering degree at a university for a few years, and then much more importantly than that, much more importantly is I worked in the field, right? So I've got like, maybe 8 years of like industry experience under my belt. But I mean, it's all just practice. Anyways, thanks for watching, guys. Catch you on the next one. Bye.